For what we will be looking into will be polynomials. And now, for what we have in the case of polynomials, okay, we're going to come up with what looks like a theoretical expression. This could look alien at first, but once we start looking into the applications, I think the picture will become much clearer. Okay, so we have an expression. So we have a of n, x to the n, plus a of n minus 1 times x to the n minus 1 and for what I have subscripted for a and superscripted for x, you have going down one at a time. And we have plus, and say we just get this down to a of 1, x to the first, and we have plus a naught. And this expression is going to be a polynomial if two conditions are met. First condition is going to be if the coefficients that you have are real numbers. Again, the coefficients had to be all real numbers. And second, for the exponents, in other words, the powers of x, we have to the n minus 1, n minus 2, and so on, are all whole numbers. And what I mean by whole numbers, for the set of whole numbers, those will be counting numbers beginning with 0. Now, in terms of distinguishing between what is a polynomial and what is not, and we'll say for the first instance, we have 3x cubed plus 2x squared plus 5. Okay. Now for the coefficients, we have 3, 2, and 5. All of these are real numbers. For the degrees of x, you have 3, 2, and 0, since we do not have an x term. Okay. And since both conditions are met, this cubic expression is a polynomial. And let's say we have for a second case, we have x to the 5th plus 3x cubed plus the square root of -7. Now in this one, okay, now for what we have in x, okay, now we have integer exponents. But for the coefficients, we've got 1 for x to the 5th, 3 for x cubed. So far we have real numbers. However, in the real number system, we cannot have an even root of a negative number. And because we have the square root of -7, this expression fails to qualify as a polynomial. Now let's say we have, for a third case, let's say we have 5 x to the 4th plus pi x cubed plus 17x squared. And in this one, okay, so we have for the coefficients, 5 is a real number. Now pi, not an integer value, but it's an irrational number that is in the family of real numbers. So pi is real, 17 is real, and the powers of which we have x to be raised, all of these are whole numbers. So both conditions for the expression to be a polynomial are met. So that is a polynomial. And let's say that for, add a case here. Say we have the square root of 7 x to the 9th plus 19 x to the 4th minus the square root of 22 times x. Okay, square root of 7, 19, and the square root of 22. Okay, all of these are real numbers. And for the powers of x, we have 1, 4, and 9. All of those are whole numbers. So the fourth example is a case of a polynomial. And let's say if we have an expression, and we'll say we have 3x cubed plus 2x squared plus 5 times x to the -1. Okay. All right, so we have 3, 2, and 5. So on the side of real coefficients, that test is passed. But now for the degrees of which we have x to be raised, we have to the 3rd power, 3 is a whole number. 2nd power, 2 is a whole number. But for -1, it is an integer, but it is not a whole number since the value is negative. And because of this, because of the -1, this is an expression that does not qualify as a polynomial. And let's say that if we have 3x cubed plus 2x squared, and we have plus 5 times the square root of x. And we have a reapplication of a radical, but this time we have it applied for not a number that is real, but for a variable, where we had the square root of x. And I tell you what, since we're looking at the degrees of x as part of the test, if we rewrite this as base x to a power, so we have 3x cubed plus 2x squared. Now, for 5 times the square root of x, square root of x, remember, your index number is at 2, x is to the 1st power, and in the rewrite, square root of x is going to be at x to the 1/2. Now, so far we have, once again, same real coefficients with 3, 2, and 5. And now, all of what we have in x must be such that x is raised to a whole number. X cubed, 3 is a whole number, x squared, 2 is a whole number, x to the 1/2, it is a positive number, but it is a rational number, but not a whole number. And so once again, just like what we had with the 5th case last term, we have an x we have raised to a non-whole number. All right. Okay, so again, you have 2 conditions must be met in order for the expression to qualify as a polynomial. And we have so just to kind of kick things off, okay, if we look into multiplying polynomial expressions, Okay, so we have in the case of multiplying polynomials, okay, just there are various approaches you might take. Some of the material you might have seen very recently, or it might have been a while since you have become acquainted with it, and you're looking at becoming reacquainted. And of course, looking at multiplying polynomials, and we have a common technique, which is the FOIL method. And the general layout for this is where you have like multi-term expressions, and the common introductions where you have like a couple of two-term expressions like a plus b in parentheses multiplying in parentheses you have c plus d. And FOIL is an acronym for first, outer, inner, and last. So if I were to multiply a plus b and c plus d, the pattern is going to be in the traditional FOIL method. You have first term is multiplying out, so you have a times c. Then you have the outside terms, or in this case the terms most distant from each other. So you have a times d. And then you have the inside will be like the terms perhaps closest together. You have b times c. And then you have the last terms multiplying, where you have b times d. Okay, so you have like first, outer, inner, and last. Okay, so this is going to be the general FOIL method approach. And some of you might have seen what's referred to as the box method. And this is going to be what's referred to as the geometric FOIL method. Again, so if you have, starting out, you have binomials. Binomials as in two-term expressions. You have a plus b and c plus d. And if you're to set up, say, a bit of a matrix, and it really doesn't matter which pairing you have as the row headings or the column headings. Say for a plus b, we'll let these terms be the column headings, and c and plus d be the row headings. But you could have it as a plus b and c plus d. In other words, reverse the row and the column headings. Okay, but just with this arrangement, in case you have a times c. As we look at the first column, say you have a times c. Then for this particular section, you have a and d, so you have plus a times d. For the second column, you have corresponding, you have c and b, so you have plus b times c. And then we have, with the completion of the second column, okay, we have b and d intersecting or interact, so you have plus b times c. And guess what? So I have the FOIL layout. So you see I have AC plus AD plus BC plus B times D. And let's say that, okay, if we take examples, and you can utilize either approach. Let's say that if we're looking at multiplying binomial expressions, and we'll say that we have, for example, let's say you have 3x plus 4. Multiplied by x plus 7, and you can go with either FOIL approach. Okay, so for what we're going to have here, so for the first terms, you have 3x and x. And then we have for the outside terms, so you have 3x times 7. Then we have for the inside terms, they have 4 times x. And for the last, you have the constants 4 and 7. Again, so we have, so you got first, outer, inner, and last. And looking at what we have for the corresponding product, so you have 3x times x. So this is going to form 3x squared. For the outside and the inside terms, now the outside 3x times 7, so this is going to be 21x. Inside we have 4 times x, which will be 4x. Last part we have 4 times 7, so this is going to be at 28. So we have, if you notice, you have 3x squared, so that is the standalone x squared term. But now for just x, and x are first order, no raised power, we have 21x and 4x, and these are what are referred to as like terms, and so they can be added together. Thus we have 21x plus 4x, which will form 25x. And then at the ends we have 28. And that would be the resulting product in this case. Okay, now another case, and let's say if we have something that is given in exponential terms. So you have something like 4x minus 3y raised to the second. Okay, so for what that 2 means, it does not mean 4x minus 3y multiplied by 2. That 2 means that if you write solely in terms of multiplication, that 2 is going to be the number of times that 4x minus 3y is going to appear when you translate in terms of multiplication. Like, had this been to the third power, this would be 4x minus 3y times itself times itself. And for this, you can use the first, outer, inner, last approach like what we did just a moment ago. But I'm just going to set this up in geometric terms. Again, you can use either approach. Okay, so I have 4x minus 3y. And 4x minus 3y, and just kind of situating what we have here. So you got first, outer, inner, and last. Okay, so for each section, okay, so you have for the first 4x times 4x, okay, this would be 16x squared. Then for the outside terms, you've got 4x times negative 3y, so this is going to be a negative 12xy. Then we have 4x times negative 3y, and putting, once again, the variables in alphabetical order. And we have 4 times negative 3 is negative 12, so you have another negative 12xy. Now for the last product, you have a negative times a negative, which is going to be a positive. 3 times 3 is 9. Y times y becomes y squared. And so for what we have in terms of the follow-through, so you have 16x squared minus 12xy minus 12xy plus 9y squared. Okay, so in the completion, okay, we have 16x squared. That is the only second degree term that we have in the letter x. Now for minus 12xy and minus 12xy, these are like terms. They're first degree in both x and y. And they have all the variables in common as well as the degrees. So we have minus 12 is going to be a negative 24 xy. Then we have the last term, we have plus 9 y squared. And it doesn't matter what order you display the final result, but as long as you got these three terms, you're good to go. And now, regarding what we have concerning the multiplication of polynomials, and we'll say that we have as the third case here, say if I have the quantity of 3x plus 4 times that of x minus 10. Again, you can go with the geometric or the traditional approach. Okay. Regardless, now the first terms, you'll have the interaction between 3x and x. For the outside terms, they got a 3x multiplied by negative 10. For the inside, we have 4 and x. And then for the last, we have 4 times negative 10. And just looking at multiplying out, so you got 3x times x, so this will become 3x squared. 3x times negative 10 becomes negative 30x. And we have plus 4x. 4 times negative 10 becomes negative 40. And so we got 3x squared. And we have negative 30x plus 4x. So this will be a negative 26x. And then we have minus 40. Okay. All right. And we'll sort of shift gears a little bit. I tell you what, just in terms of multiplying polynomial expressions, let's see what we get for, and we'll say that we have let's say 4x plus 3 times the quantity of 4x minus 3. And also, let's see what we get for 3x minus 8z raised to the second. So for just the next few moments, let's see what products we get for these particular sets. Okay, some of you might still be working on these items, and that's okay. Now for the first one, okay, now we have almost identical binomial expressions, except for the first one we have addition, whereas with the second we have subtraction. And again, you can use either FOIL approach. Now for the quantity of 4x plus 3 times that of 4x minus 3, if you already see the result, that is fine. I'm just going to break this down incrementally. And so for the first terms case, we have 4x and 4x. And we have with the outside terms, we have 4x and negative 3. Then we have 3 times 4x. And the last term, so we have 3 and negative 3. And we have in terms of the follow through, okay, so you have 4x times 4x. So this will be 16x squared. And then we have 4x times negative 3, so this will be a negative 12x. Then we have for the inside product, we have 3 times 4x, so this will be a positive 12x. Then we have 3 times negative 3, so this will be a negative 9. And in terms of the follow-through, okay, so you have 16x squared. And if you notice, we have what are referred to as additive inverses with negative and positive 12x. So those are going to completely cancel each other out. So there's not going to be a first order x term. And so instead of having 3 terms at the end, we have only 2. And this particular result is going to be a sample of what is going to be referred to as a difference of squares. In other words, okay, like 16x squared is 4x times itself, and 9, again, that is like 3 times 3. So you're looking at the difference of the squares of 4x as well as 3. Now, as for what we have in the case of the square of 3x minus 8z, again, either approach can be taken. Now in the case of 3x minus 8z squared, so you have 3x minus 8z times itself. Again, you can utilize either the traditional or FOIL, or traditional or geometric FOIL approaches. Okay, so for what we have in this particular case, right, so you have 3x times 3x, okay, so this will make 9x squared. You have 3x times negative 8z, so we will have negative 24xz. 3x times negative 8z, have another 24xz that is going to be subtracted. And then we have negative 8z times negative 8z, that's going to be a positive 64z squared. And so just gathering the terms here, so you have 9x squared minus 24xz, and another negative 24xz. And we have plus 64z squared. And we have, for the result, we have 9x squared. And we have like terms in the middle. In fact, they are identical to each other. And combining, we have a negative 48xz. We have plus 64z squared. And I'm just going to mention something here. Okay, I mentioned earlier case was where we had a difference of squares. And when we looked at the square of a binomial expression, anything that results from the square of a binomial expression and that ends up as a trinomial, this particular case, and this is like in reference to the exponent 2, this result is going to be what's referred to as a square trinomial. In other words, the square trinomial, if you factor, comes out to identical binomial expressions in factoring. Same thing here. Okay, and now going in the essentially the other direction. Now we looked at multiplying polynomials, but now in terms of crossing over into the realm of factoring. So we're going in the other direction instead of going from the factors to the product. We're going from the product to identifying, okay, just what factors are going to be involved. And let's say that if we have, just something that I think is fairly ideal introductory example would be if you were to factor, say, the trinomial x squared plus 7x plus 10, and you can ask, okay, what expressions would multiply into this particular trinomial? Okay, so we have from x squared, if your first term is x squared, or whatever the square of the variable is, it's just going to factor out to two terms in the same variable. Like x squared will go to x and x. And as for the 7x and the 10 part, okay, now you're going to ask, okay, what two numbers will multiply into 10 and at the same time will add up to 7? Okay, so you have positive terms throughout. So we'll have addition in both factors, one of which will consist of a positive 2 and the other a positive 5. And it does not matter what order you place the factors. It could have been 5 at the front and 2 as the second constant. So you could switch the order of the factors. Now, if we have, let's say, going back to another difference of squares, we have something like x squared minus 64. Again, notice we do not have an x term of first order that is present. And you can sort of, if you're try to envision as a trinomial, well, to represent a void, you could say that we have 0x. 0x is still 0. And in terms of what we have with x squared, once again, we can still factor to x and x. And factors of negative 64 whose sum or difference will be at 0. You're just going to have the same weight for the addition and the subtraction. So this will become x plus and x minus 8. And let's say that we have, kind of going back to a squared trinomial. If I were to have something like x squared plus 20x plus 100. Okay, so if I factor, okay, so x squared goes to x and x. Factors of 100, that will add up to 20. Then we have positive 10 in both of these. And if you notice, we have x plus 10 times x plus 10. And this will come out to the square of x plus 10. Okay. So again, we have another case of a squared trinomial. Now, say just another case here. Say if we have an x term of first order that is negative. Okay, so you have x squared minus 10x minus 24. Okay, so for x squared again, so we have x and x. And for negative 24, Okay, so you have factors of negative 24 that will add up to negative 10. So this is going to signal that more weight is going to be given to the subtraction than to the addition. Okay, so for negative 24, okay, negative 24 has all kinds of combinations, but where the factors will add up to negative 10, we have on the minus side is going to be 12, and on the plus side we have only 2. So your factors will be at x plus 2 and x minus 12. And now, in the case of just factoring polynomials, okay, now still with the leading term at x squared, and I guess in a sense there is a bit of a comfort zone factor with the leading term at x squared, but we're going to just eventually leave this behind and look at square terms that will have coefficients greater than 1. But for what we have in the meantime, I'll tell you what, let's see what we get for factoring, say, x squared minus 36 as well as x squared minus 12x plus 36. Okay, for the first item we have a difference of squares, okay, where we have x squared minus 36, and the layout's very much like what we had earlier with x squared minus 64. Okay, you don't have a first order x term, so that's signaling that the factors will have constants that will be identical in terms of what will be added and subtracted. So for x squared minus 36, okay, we have a difference of squares. So x squared will factor out to x and x. And for factors of negative 36, you're adding and subtracting the same amounts, and that times itself, which will give you 36. That will be the number 6. So we have x plus 6 and x minus 6. Now, for x squared minus 12x plus 36, okay, here we have where the first case is a difference of squares. This one is another case of where we have a square trinomial. Now for x squared, this is going to factor out once again to x and x. And for factors of 36, now the way that two numbers can multiply into a positive product is for either both numbers to be positive or both numbers to be negative. And since we're looking at where the product is positive 36, but where the sum is going to be negative 12, we're going to have both factors to be negative. Okay, and so in this case, that times itself, which give you 36, that is negative. This will be minus 6, and minus 6, since negative 6 and negative 6 add up to negative 12, and since we have a square trinomial, we have in factoring, we have only x minus 6 factored out. And since x minus 6 repeats once, okay, we have for the condensed solution, okay, this is going to end up as the square of the quantity of x minus 6. Now, again, so far we've looked at factoring polynomials whose leading term is x squared. And the techniques would be the same if you had like the terms or the polynomials in one variable, and your first term had to be like z squared or u squared or y squared or b squared. But just kind of sticking with the x right now, and say if we have a leading term that is other than just x squared, and say that if the factoring is not quite so intuitive, we can perform what's referred to as factoring by grouping. Now for what we have in the case of factoring by grouping, okay, let's say if you're looking at factoring So like 3x squared plus 19x plus 20. Okay, so now this is a factorable trinomial expression. Okay, but 3x squared, thanks to the 3, okay, the leading term is not automatically going to go to x and x. Okay, and okay, just kind of using this now. It would be like 3x and x, but just to kind of show this as a bit of a springboard example for the factoring by grouping process. Now, what you're going to do in terms of initiating the steps, okay, is that you're going to look at first of all the first and the last numbers. First number at 3, last number at 20, and you're going to multiply them together. Okay, so you take the first and the last numbers, multiply together. So the product is going to be at 60. Now we're going to involve the number 19. And now that we have the product at 60, we're now looking for factors of 60. Whose sum will end up at 19. Okay, just kind of mentioning once again. So we just involved 3 and 20. 3 times 20 is 60. However, 3 plus 20 comes out to 23, and we want the numbers to add up to 19. Okay, so 3 and 20 is not the combination. But if I take 4 into 20, 4 into 60, 4 will go into 60 15 times. Okay, so I have all combinations. 3 and 20, 4 and 15, 5 and 12, 6 and 10. But out of the combinations that will add up to 19, we have 15 and 4 involved. Okay. And since this is the combination here, 4 and 15, and it doesn't matter what order you place them, but in terms of the 4 and the 15, how they're going to be used, they're going to be x terms that will be formed upon splitting the first order variable term in the middle. So we have in the rewrite, so we have 3x squared. We could either have 15x or 4x at the front. So just looking at what we have here. So next stage is where the grouping is going to come in. So we have 2 pairs of terms. And I'm going to put in parentheses the first 2 terms. So I have 3x squared plus 4x. And we have separating the first 2 from the last 2 terms. We have the operation in the middle, which is addition. And I'm going to take the quantity 15x plus 20. And just taking what we have now. Okay. So you got 3x squared plus 4x, and I'm going to draw out the greatest common factor of these 2 terms. And so between 3x squared and 4x, the highest term is going to be at x. And x will go into 3x squared plus 4x, and this will be 3x plus 4 times. And bringing down the addition. Okay, now we have for the greatest common factor of 15x and 20, the highest term that will go into both 15x and 20 is going to be a number, and that is going to be 5. And 5 will go into 15x plus 20, also 3x plus 4 times. And for the two factors, one factor is going to be that which is repeated from the separate groupings and resulting factoring at this stage. So you got 3x plus 4 is that which is shared in this particular layout. And the other factor is going to come from the outside terms and operations. So on the outside we have x and positive 5. So we have our two factors, going to be 3x plus 4, and also the quantity of x plus 5. And you can just sort of check for the consistency. So again, you have 3x times x is 3x squared. 3x times 5 is 15x. We got 4x. 15x plus 4x is 19x. And we have plus 20 at the end. And now, another case of what we have with factoring by grouping. And we'll say that we have a negative term in the middle. Okay, so you have 10x squared minus 23x plus 6. Okay, so we have here, for this trinomial, again, in the process to initiate, so again, we're multiplying the first and the last coefficients. And this time we have 10 as the first, 6 as the last. Okay, and we had this product is also going to be at 60. And this time around we'll be looking at factors of 60 that will add up to negative 23. So for what we have here, okay, so we just dealt with 10 and 6 added together, so that would be 16, positive 16, but we want to go in the direction of negative 23, so we want both factors to be negative. So like if I had negative 10 and negative 6, some would be negative 16. So I need another combination. Say if I go with negative 20 and negative 3. Negative 20 times negative 3 is positive 60. And adding together negative 20 and negative 3, then we have it negative 23. And that's the combination we're looking for. So looking at what to do with negative 23x. Again, that's going to be split into two first order x terms with these coefficients. So I have 10x squared, and I'll say I have minus 20x minus 3x plus 6. Now where the grouping stage is now going to occur. Now for the first two terms, we have 10x squared minus 20x. Now if you notice before, the operation in the prior example that was in the middle was addition. But here we now have the operation to be subtraction. And once you quantify that which represents minus 3x plus 6, you had to be careful with this one. So minus 3x is the opposite sign of 3x. And 6 is the opposite sign of negative 6. So just think about what would happen if you remove the parentheses. So we have 10x squared minus 20x, and you have minus 3x, and then minus 6 translates out to plus 6. Now, in drawing out the greatest common factors from each pairing, so for 10x squared minus 20x, okay, so we'll have 10 for the number, and both of these are variable terms. So the greatest common factor is going to be at 10x. 10x into 10x squared becomes x. 10x into negative 20x is going to be negative 2. And I want to bring down the subtraction. Now for 3x minus 6, now the greatest common factor of 3x and negative 6 is going to be 3. So I'm pulling out the 3, and 3 into 3x minus 6, okay, that is going to be x minus 2. And so for the factors here, notice, okay, we have from the groupings, okay, we have x minus 2 is common, and the other factor is going to stem from combining the terms outside. So you have 10x and negative 3. So those would be the factors in this case, right? And you can, again, double check. X times 10x is 10x squared. And we have minus 3x minus 20x, which is negative 23x, and negative 2 times negative 3 is a positive 6. All right, and tell you what, just in the case of looking at factoring, okay, just for the next few moments, let's see what we get for the binomial factors of these three particular trinomials. Tell you what, if we go ahead and look into what we have for these three problems, okay, if you're still working on these items, okay, that's okay. We have for the first one, okay, now the leading term, okay, we have x squared, and here we have for this trinomial, okay, x squared minus 2x minus 80. Okay, again, we have for x squared, okay, this will factor out to x and x. And for the factors of negative 80, whose sum or difference will end up at negative 2, okay, this is signaling that more weight will be given to the factor of subtraction than to what will be in what we have for subtraction. Okay, so you have more weight given to the subtraction than to the addition. Okay, so we have for factors of negative 80, whose difference will be at negative 2. Okay, we're going to have x plus 8 on the plus side, and on the side of subtraction, we're going to have x minus 10. So again, we have x squared, negative 10x plus 8x becomes negative 2x, and 8 times negative 10 becomes negative 80. All right. Now, for what we have in the second and third items, okay, we have in these now factoring by grouping again is a viable route, okay, to getting to the factors of these particular trinomials. Now again, if I look at factoring by grouping, what I have here, so for 4x squared plus 19x plus 12, okay, so if I multiply the first and the last coefficients, so I have 4 times 12 is going to be 48. And if I look for factors of 48, that will add up to the middle number, 19. Okay, so we start out with 4 and 12. And of course, 4 and 12, okay, will add up to 16. So I'm looking for another combination, and we can say we have, say, 16 and 3, or 3 and 16. Doesn't matter the order. 16 times 3 is 48. 16 plus 3 is 19. And so we have for initiating the process, factoring by grouping. So the 16 and the 3, they will form x terms upon splitting the 19x. So for 4x squared plus 19x plus 12, we will have 4x squared plus 16x plus 3x plus 12. And looking at factoring by grouping, okay, first of all in grouping, so we have the first two terms, 4x squared plus 16x. Now we have for the middle operation, okay, we have addition. Again, so you have the addition sandwiched in the middle. And once we put in parentheses, okay, so 3x plus 12, there's no negative to factor out. So removing the parentheses, you still had the same four terms. And looking for the greatest common factor of each pairing. So for 4x squared and 16x, this will go to 4x. And taking into 4x squared plus 16x, we have the quantity of x plus 4. And bringing down the addition. Now the greatest common factor of 3x and 12 is going to be at 3. And 3 into 3x plus 12, that is going to be x plus 4. And if you notice, we have a common factor from the pairings, okay, with x plus 4. And the other factor is going to stem from the outside terms and operations. So we want to have 4x plus 3. So we have, in effect, okay, so for 4x squared plus 19x plus 12, okay, this will come out once again to the quantity of x plus 4 times that 4x plus 3. Okay, and for what we have in the third and final case, okay, so we got with 12x squared minus 13x plus 3. Okay, so looking at setting up the stage, okay, for factoring by grouping, so leading and last coefficients are 12 and 3. 12 times 3 is 36. And for factors of 36, whose sum will be at minus 13. Just to mention, in case you had 12 and 3, 12 times 3 is 36. However, 12 and 3 will add up to positive 15. We want the sum to be at negative 13. And for this combination, okay, this would be with the numbers negative 4 and negative 9. Okay, the product is 36. However, negative 4 plus negative 9 is negative 13. Okay. And so just looking at splitting up the middle term. Okay, so we're going to have 12x squared. You can see we have minus 4x minus 9x plus 3. And once we group in parentheses, okay, so you got 12x squared minus 4x. Okay, now we got the middle operation as subtraction. Not addition, but as subtraction. So once I put in parentheses, I'm not going to have 9x plus 3 or negative 9x plus 3. Now, minus 9x is the opposite sign of 9x. Positive 3 is going to be the opposite sign of negative 3. Again, remove parentheses, 12x squared minus 4x. Remove the second set, you're multiplying the last two terms by negative 1, so we have negative 9x plus 3. Now, looking at drawing out the greatest common factors for the first pairing. For 12x squared minus 4x, greatest common factor is at 4x into 12x squared minus 4x, so this is going to be 3x minus 1. Bring down the subtraction. Now, looking at just 9x minus 3, okay, greatest common factor is going to be at 3. 3 into 9x minus 3 is going to be the quantity of 3x minus 1. And this time we have our shared factor at 3x minus 1. And the other factor is going to stem from the outside terms, and so combining we come out to 4x minus 3. And again, you can go back and check. 3x times 4x is 12x squared. And we got 3x times negative 3 is a negative 9x. Negative 1 times 4x is a negative 4x. Negative 9x minus 4x is a negative 13x. And we have last, negative 1 times negative 3 is a positive 3. And that would be your final result. All right, and now just some items to go ahead and be looking into. And this is not to turn in. Some of you, let's see, might be awaiting source materials, but anyway, for practice, we have from the textbook items to go ahead and be looking into, and we have from page 41, number 77, 87. 91, 94, also 102, and also 106.